Hey everyone, I am K.Harshith. Today I am here to explain the concept of hydrocarbons. This is a particular topic that is from the lesson carbon and its compounds. As the name itself says, hydrocarbons, which means that it's a compound which is possessing of hydrogen and carbon. Now as you can see, here I have represented the types of hydrocarbons. Now basically the hydrocarbons are divided into two, that is open chain, closed chain. Means the carbons and hydrogens in the compound are arranged in acyclic manner or in cyclic manner. As the name itself says, acyclic means it is not in a cycle format. It's like a chain, it's like a straight chain like structure. Here it's closed, means it is having a closing and it's in the shape of a cycle. Now open chain is again divided into two types, saturated and unsaturated. In saturated we learn only about alkenes, and whereas in unsaturated we have again two types, this alkenes and alkynes. And in closed chain we have three types, cycloalkane, cycloalkene, cycloalkynes. Now this is the overall view of the chapter. Now let us just draw a rough sketch like thing for each of the hydrocarbons. Now alkanes, let us study a bit about alkanes. Now if we see alkanes, now alkanes, these alkanes are saturated, which means that now this is the, let me say, CH4. It's a hydrocarbon, it is having only carbon dioxide or only hydrogen. If you see the arrangement of carbon and hydrogen for this, it would be like this, CH4, which means here in alkanes all the bonds between the carbon will be single. Now if you see there are two carbons, if there are two carbons then the bond will be only single bond. If there are three carbons then three single bonds would be possible in alkanes. So we can write one characteristic under alkanes as have single bond between carbon and carbon. Now alkanes have only a single bond between one carbon and another carbon. Now to know whether this is in is it an alkane, alkene or alkyne, we use the compound or we use the general formula to check whether it's an alkane or alkene or alkyne. The general formula to find out whether it's an alkane or alkene or alkyne, or to know if they have given the number of carbon atoms, how to find out the number of hydrogen atoms, we use the general formula CnH2n plus 2. Now if you see Cn, let me take the number of carbon atoms as 3. Now there are 3 carbon atoms. Now what about the hydrogen atoms? It will be 2 into n is 3, so 2 into 3 plus 2, C3H, 3 2s are 6, 8, C3H8. This is the use of general formula. If there are 3 carbon atoms then there would be 8 hydrogen atoms in alkanes. Now how to draw the structural formula for this compound C3H8? Now if you see there are 3 carbon atoms, I am drawing 3 carbon atoms. That's an alkane, which means a single bond between all the carbon atoms, and it should have 8 hydrogens. So put all the hydrogens to the carbons. Now this will have 1 hydrogen here. It should satisfy the tetravalency, which means it should have 4 valence electrons to each carbon. Now this is 1, this is 2, and here 3, here 4. Done. Now for this you see 1, 2, here 3, here 4. This is done. Now for this 1, which means 2, 3 and 4. Now you see 1, 2, 3. 3 CC bond, 3 carbon atoms are there. 3 carbon atoms are there, and 1 2 3 4 5 6 7 8 8 hydrogens are there. There are 3 carbons and 8 hydrogens. Now let us see the number of single bonds between them. Now you see, count the number of bonds here. Now here 1 2 3 4 5 6 7 8 9 10 10 covalent bonds. Now there are 10 covalent bonds in this compound C3H8. Now how to find out without drawing the structural formula? Now you see, there are 8 CH bonds. There are 8 CH bonds, and here if you see 2 CC bonds. 2 CC bonds. Now you see 1 1 2 CC bonds. So 8 plus 2 gives 10. 10 single covalent bonds. For C3H8 there are 10 covalent bonds. Now how to name this compound? What is the IUPAC name? We will study it afterwards. Just let us have a rough idea about all the compounds now. Coming to alkenes, it is unsaturated, means it will be having one double bond between carbon atoms. Only one double bond. Many people they keep it like this. They keep double bond for all the carbon atoms, which is wrong. Now the general formula for alkenes is CnH2n. Now same, I'll take C as 3, C3, H, 2 3s are C3H6. Now is this representation correct or wrong? Now if you see, there are 3 carbon atoms, perfect, but hydrogen atoms 1 2 3 4 5 6 7 8, but we need only 6 hydrogen atoms. So here, as it is an alkene, we need to add a double bond. So I am adding a double bond. Here we need to add double bond only to a carbon and a carbon. We can never add like this. Okay, so now I am putting a double bond between this carbon and this carbon. Now you see, 1 2 bonds are done. Now this requires only 2 bonds. Now also if you see, 1 2 3 4 5 6 7 are there, but we need 6. Here if you see, once again, here see the middle carbon compound, 1 2 3 1 2 3 4. There is no requirement of this hydrogen here, because you see 1 2 3 4 tetravalency is done. If you put here another H, it will not become a tetravalency. So like this. Now I have added one double bond between CC, and now you check the carbon atoms. C, 3 carbon atoms, perfect, 3 carbon atoms. Now you see hydrogen, 1 2 3 4 5 6 hydrogen atoms, perfect, C3H6. Now the number of bonds, now 6 CH bonds are there, and 1 2 CC bonds are there. 8 bonds are now, or let me divide it furthermore. 6 CH bonds, 1 C single bond, and another C double bond. 6 7 8, total 8 bonds are there. We cannot say here 8 single bonds because there is one double bond. So we can say it is having 8 covalent bonds. We can say it is having 8 covalent bonds. This is about alkenes. Now let us study about alkynes. Coming to alkynes, this will be having one triple bond between carbon atoms. Now, so alkynes means what? We will be having only one triple bond between the carbon and a carbon atom. The general formula for this would be CnH2n minus 2. Now alkanes is CnH2n plus 2, alkenes is CnH2n, alkynes is CnH2n minus 2. Now let me take the same C3 H2n means 2 3s are minus 2, C3H 2 3s are 6 minus 2, C3H4. Now let me draw the structural formula. 3 carbon atoms and 1 triple bond should be there. So add 1 triple bond between any of the carbon here, or you can even add here. But you need to be careful to check the hydrogen bonds wherever you are adding. Now if you see here, only 1 is there, so rest 3 will come here. Here 1 2 3 4, which means for this central carbon atom there is no requirement of hydrogen to satisfy the tetravalency, because here 3 bonds, here 1 bond, this is satisfied. Now here if you see for this carbon 1 2 3, one more requirement of hydrogen. Now you see there are 3 carbon atoms, 1 2 3 4, there are 4 hydrogen atoms. 3 carbon atoms, 4 hydrogen atoms. Number of single bonds, now number of bonds you see 4 CH bonds, okay, 4 CH bonds. Then next 1 C single bond C, 1 C triple bond C. So totally 4 5 6 covalent bonds. You cannot say double bond, 6 single covalent bonds, because 1 triple bond is there. Never count the number of bonds like this 1 2 3 4 5 6 7 8, because this all the 3 represent only one bond. 1 2 3 4 5 6, need to count like this. Never count these 3 bonds separately. These three triple bonds combine to form only one covalent bond. 1 2 3 4 5 6, so 6 covalent bonds. I hope you have understood the open chain structures of hydrocarbons. The closed chain structures we will be seeing or studying about them after learning everything about alkene, alkane, alkene and alkynes. Once again let's recapitulate. Alkanes are nothing but the compounds having single bond between C and C. The general formula is CnH2n plus 2, and I have took an example C3H8 and I have shown you how will the structural formula be for this particular compound, and then how to count the number of bonds. Similarly for alkenes also, 1 double bond between carbon and carbon, and then the general formula CnH2n, and then the example and how to count the number of covalent bonds. Similarly for alkynes also, 1 triple bond between carbon atoms, the general formula CnH2n minus 2, okay, and I have took the example also. The general formula is very important, because based on this we can say, when we learn the IUPAC names of the compounds, then the general formula will be useful. So we take n as 1, so C1, and then substitute the value of n in the place of hydrogen, we get the compound and we can name that. Those all things we learn in our next video. I hope you all have understood something, you have got an idea about hydrocarbons, especially about open chain hydrocarbons. Thank you.